Right. Not at all. Yes. Sorry. Okay. Not at all comfortable with the unit circle. Okay. On the unit circle is the one thing that we probably use the most. So far over. Okay. All angles, when we start with your circle, all angles rotate, unless we say otherwise, counterclockwise. They rotate counterclockwise. They all start from this axis, the positive x-axis. This is called your initial side. They all start from here and they rotate counterclockwise. If it's a negative, it'll start here and rotate clockwise. Kind of goes the opposite way that you would think. Now that's why we label our quadrants. 1, then the next one we come to is 2, then the next one we come to is 3, then the next one we come to is 4. Okay. When we open an angle, so say I go 30 degrees. This is 30 degrees. This is called my terminal side. Write this down. This is called my terminal side. This is my angle, 30 degrees. From here, I'm going to drop a triangle right at that edge of the circle, down, a right triangle. Okay. This piece here, what axis is this on? My X. This is my X. This piece here, it's not on an axis, but what is it parallel to? Where does it intersect? The Y value. This is my Y. The terminal side of my angle is what part of my right triangle? The hypotenuse. This is also my radius. Isn't it also the radius of your circle? So we're going to identify the parts. On a unit circle, as on any circle, any point that comes on my circle has an XY point. Now what makes the unit circle unique is your radius is 1. It's 1 unit over, 1 unit up, 1 unit down, 1 unit left. So everything goes 1. Now, if we took our special triangle, meet anyone that you know, Jackson, what's opposite 30?
Opposite 30 would be the 3 squared. Or opposite 2. 1.
Okay, opposite the 30. Which one's the biggest angle? Which one's the smallest angle? 30. So it's going to say 1, 2, 3. This is how your easy way to remember it. 1, 2, 3 is what you're going to use on your 30, 60, 90. Opposite the 30 is the smallest side. It's going to have the smallest number. 60 gets a little bit bigger, and 90 gets the biggest size, right? The sides get bigger as the angles get bigger. So 30 is going to be my 1. One of these has to be a radical, can't be my 1. It's going to be this guy, because now it's about 1.732. It's less than 2. The biggest one is my hypotenuse. So now, if I was to put this over here, I need this guy to be 1. So what do I divide 2 by to get 1? I divide by 2. So I'm going to divide everybody by 2. This is because I'm working on a unit circle. So this guy is now 1. This guy is now radical 3 over 2. And this guy is 1/2. So my point on my circle is my X point, comma, my Y point. Now, yesterday I told you a little trick. On the unit circle, because we did your quadrants, we did them out here. The X, the Y, the cosine, the sine. The cosine, the sine. On the unit circle, because my hypotenuse is 1, my radius is 1, if I put opposite over hypotenuse, isn't it just the 1/2? So wouldn't the sine of 30 be the opposite over the hypotenuse? 1/2, right? Sine is my y value, cosine is my x value on a unit circle. Yes. That's good? That's cool? Now, here's the other problem. On a unit circle, notice we're dealing with x's, y's, and r's. We're not dealing with opposite, adjacents, and hypotenuses. We are now transform them onto a unit circle. So this technically, yes, is my opposite. This technically, yes, is my adjacent. And this is my hypotenuse. We're going to play with this just a little bit. So you memorized SOHCAHTOA. We're going to transform this to your unit circle. Sine, cosine, tangent. On my unit circle, what represents my hypotenuse? R, my radius. Okay. On my unit circle, I've got an X and a Y, and what letters do I have left? O and A. What comes first in the alphabet? A, O. So now, every time I see an A, I'm going to replace it with an X. Every time I see an O, I'm going to replace it with a Y. Hang in there, hang in there. So sine is Y over R. Cosine, X over R. Tangent, Y over X. Easy, easy transformation here. I want you to start thinking in terms of X, Y, and R. It's not so bad when you're in quadrant 1 with the opposite and the adjacent thing, but when you get to quadrant 3 and your triangle is upside down, then you got to start. This is my opposite, this is my adjacent, this is my hypotenuse. And I usually have a good quarter of the class that still likes the opposite, the adjacent, the hypotenuse, until you get used to the X, the Y, and the R. The X, the Y, and R actually work a little bit better when you're doing the reciprocals. So once we get to this point, we're going to write a little information box. And we're always going to say X equals, Y equals, R equals. So my X in this case is my radical 3 over 2. Is it positive or negative in this quadrant? Positive. My Y is 1 over 2. And my radius is 1. Okay, so if I found the sine, cosine, tangent, can I do that off of these? Which you have on your sheet from yesterday, from the couple days we've been doing this, right? Now, if I continue with this, and I bring this around, I keep going past the 30, and I come around here and I stop, and this angle right here is 150 degrees. I'm going to drop a triangle always down to the x-axis. What reference angle is right here? 30. So on my unit circle, shouldn't this triangle be the exact same as this triangle? Yeah. Yes. So I'm going to label this 1/2, 1, radical 3 over 2. Hang on one second. Now those are the distances from here to here. I happen to keep those positive. If you like to put your negative there, that's fine. What's the point here? This point is an xy point. Is x positive or negative here? Negative. Is y positive or negative here? Positive. So now when we make our information box, we're going to say x equals negative radical 3 over 2, y equals 1/2, and r equals 1. So that's all I need to look at when I make my sine, cosine, tangents of a 30 and a 60 degrees. That's all I need to look at. Agree? I know what they are now. Sine is my y. Well, if I didn't say that either, I could say y over r, 1/2 over 1, 1/2. Cosine, my x over r, negative radical 3 over 2 over 1, which is negative radical 3 over 2. My tangent, y over x. when I flip this over, this cancels out and I get negative. And isn't tangent negative in quadrant 2? Did you guys learn all students take calculus? Or something like that? Crack. If you have Mr. Schaefer, all students take crack. You gotta start in this quadrant, the way you rotate. All students take calculus. So, or chemistry. Usually you guys are taking chemistry, right? Are you taking chemistry? Last year. Okay, so not chemistry. Calculus. So all means that everybody's positive. S means that only sine is positive. T means only tangent's positive. And C means only cosine is positive. But if you really don't have to know that, as long as you superimpose that angle onto this grid, because this is an xy axis. This tells you x is positive here, y is negative here. So when I'm down here, my cosine is my x, right? So my cosine is positive. Everything else is going to have a negative in there. If I'm in this quadrant, my x is negative, my y is negative. The only thing that could possibly be positive is a tangent. Negative divided by a negative, right? So this is how we're going to rotate your angles. Okay? It's going to take a little while to digest, I get it. Where is my list of my thing? Okay, so let's work on a couple more here. I don't know why Oh, well, I'm going to show you in a second. Actually, we've been doing this, but for some odd reason, you didn't get this paper. So, let's do this. Write this down. What quadrant would I find this angle in? I'm on my unit circle. What quadrant is that angle in? Where does the negative rotate? Clockwise. So, what is this angle? In the fourth quadrant. How many times does 3 go into 180? 60. Okay. We just did a 30 and a 60. We said opposite the 30 was 1/2. Opposite. Nope. How many times does 3 go into 180? So this is your reference angle right here. All your reference angles are inside. When you're done with this, this will look like a bow tie. Did you learn those? No. Oh my God. It will look like a bow tie. So whenever you're dropping triangles, picture me wearing a big red bow tie. My bow tie can't go like this way, can it? It can't go off the y-axis because I wouldn't be able to put my chin down. So picture me wearing a bow tie. It goes like this. So technically, every 60-degree angle will fall in here. They will all have the same measurements. All your radiuses will be 1. Opposite this one is radical 3/2. And these guys are the 1/2. Now, what matters is what quadrant you're in. So in this quadrant, is x positive or negative? Is y positive or negative? And a radius is always positive. So from this, can you do your sines, cosines, tangent? Okay, one more. All right. I don't think you're going to be able to do much of this homework. Try it. Try the homework. It's not that much. What I want you to do, guys, try it. Put it on unit circles. Guess where the angle comes out of unit circles. And we'll do those again on Monday. This is just a slow process.
You really want to?
No more triangles, guys.
Exactly, so bad. I'm sorry. Don't worry.